Notice it. This is what we used to call as formula for instantaneous velocity. So what we'll do, we'll keep here a arrow and we'll keep here bar for delta S. So what do you mean by delta S? This one, change in displacement. Do you understand what do you mean by delta? Change in the displacement in a small interval of time delta t. What is this? Change in a displacement in a small interval of time. What is the time, Ra? Time is delta t. So that is what we used to call as instantaneous speed. Is it okay, guys? Any doubt? Now, sorry, instantaneous velocity. Now, let us take. We know that we are having body will move with two kinds of velocities. What is that? Either it will be in uniform velocity or with the what? Non-uniform velocity. So now, in both the cases, or else we can say commonly, don't take speed and velocity. Other than that, we can say body is in two kinds of motion. What is that motion? Anybody?
Uniform motion, non-uniform motion.
Non-uniform motion.
Non-uniform motion. Clear? Uniform or non-uniform motion. So then you can see, sir, how to find the instantaneous velocity at any instant is given by the slope of the tangents drawn at a point in the displacement time curve. So we'll give you always instantaneous velocity. So now, sir, what it is? Let us take. So we are having two kinds of graphs. What is that graphs, guys? One is what? Uniform motion graph, and another one is what? Non-uniform motion graph. Now, uniform motion graph, how it will be there? Last class I taught you. How is the uniform motion graph? If you take, it is the straight line. Yes or no? Uniform motion graph, if you take, it is the straight line. So now, if you take non-uniform motion graph, how it will be there? Non-uniform, it will be curved path. Like this, it will be there. So here, what will come? X-axis time, and here distance or displacement. You can take. Now we are talking about velocity. So what we have to take? Distance or displacement? Displacement will come time. So this is uniform or non-uniform? Uniform motion, and this is what we used to call it as non-uniform motion. Is it yes or no? Yes, please respond. Now let us see how to find instantaneous velocity from this uniform and non-uniform. So as I told you, if you want to find uniform, like instantaneous velocity from both the graphs, what you will do means, for example, see, from here, this is the total journey of Harish. Do you understand, Harish? Danishkar, this is the total journey of yours. Now, at these 2 points, I want to know your velocity. So that is what we used to call it as what velocity we can say? Uniform instantaneous velocity. Now, same way, here, let me imagine Reddy is traveling. Now, this is the total velocity. This is the total journey of Reddy. Now, at this particular point, now I want Reddy velocity. That velocity only what we used to call instantaneous velocity. So, this is how we can get it. Instantaneous velocity means just draw the tangent. Mathematics, you will find the slope of a graph. Do you remember? Mathematics, you will draw the slope of a graph. Do you remember, guys? Please respond. So if you remember the graph, so how you will find the slope of the graph? The same way here, if you draw the slope of the graph, then the slope of the graph only we can draw. This is only ways to call it as tangents. What is to call? If you draw the tangent, then the tangents will give you what? The tangents will give you what, guys? Instantaneous speed. Do you understand? Instantaneous velocity there will be. So a velocity at any instant is given by the slope of the tangents drawn at a point, understanding, into the displacement time curve. So that is what you have to remember. So always the slope of tangents. This is only mathematics. What we used to call, guys? Slope. Yes or no? So the slope of these tangents which we have been drawn towards to the displacement and time graph will give you instantaneous velocity. Is it okay, everybody? Now I will show you. Vardhini, now you joined, what you will understand? Nothing you will understand. Okay, that's now this is the two graphs. One graph is uniform motion, another one is non-uniform motion. Which one is uniform? Which one is non-uniform? Anybody?
First one is uniform.
So
sir.
first
Second
diagram is a
Yeah,
uniform
first
and
one
second
is
diagram is a
uniform motion.
non-uniform.
Very good, all of you. See what happened, Tanishkar, today not all speaking. This is uniform motion, and this is what we used to call as what, guys?
Non-uniform.
Non-uniform motion. Is it yes or no? So now I want to find the instant velocity between the points where to where? From point A to B. From point where? From point A to B, and here also from point A to B. Is it okay, everybody? Is it yes or no? Yes, please respond. Now, what is instantaneous velocity formula, Harish? Arun Kailas, what is instantaneous velocity?
Delta S by delta T.
Divided by
The delta S by delta T.
delta T. Is it yes or no? That's all. Very good. So now delta S divided by delta T. Now, but from this graph, I want answer. Anybody can tell me from this graph, what is the instantaneous velocity? Both. In case of variable velocity and as well as uniform motion or non-uniform motion, whatever it is, non-uniform motion. So what is the instantaneous velocity? Anybody can tell me. First, distance. So distance means which one you can take. So distance, not displacement. So shortest path. So check it. What is the displacement? What is the displacement, guys? Graph, you can check it. You can understand. So what is the displacement here? This is the displacement. So this is the point and this is the point. I want instantaneous velocity between A to B. Is it Esra? Yes? Please respond.
Yes,
now, what is the formula? Delta S divided by delta T. This is the formula. Now, what is this delta S? You tell me. This is what delta S. So, what is this delta S? Please respond. B and C. That is what I said. Slope of the tangents. Yes or no? Harish?
Yes, sir.
So this is the slope. What is the slope? This is the slope of the graph. This is the slope of the graph. Now you tell me, this tangent is called as BC, and this tangent, what we used to call, guys? What we used to call? AC. Now you tell me, in BC and AC, which is displacement, which is time? Which is displacement, which is time? Which is displacement and which is time? BC is representing what? Displacement or time? BC. You just check it. It is representing what? BC. It is representing what time? Where it is representing time? BC is equal to
displacement.
See, delta S is parallel to BC. Is it yes or no? Yes or no? So if delta S is displacement, means BC is also will become what?
Displacement.
AC is parallel to delta T. AC is parallel to delta T. So means delta T is becoming what? Delta T is becoming what? AC. Yes or no? Time period. So from this graph, if you want to find instantaneous velocity, so what is the formula? Slope only, that's all. So what will come? What is the formula, guys? BC divided by AC. Is it yes or no? Which is equals to delta S divided by delta T. That's all. Now, in this graph, you tell me. Let me see who will say in this graph. In this graph also same thing. So this is what? Displacement, delta S. And this is what we used to call as delta T. Now you tell me, what is the formula from this graph also? Instantaneous velocity is equals to. So what is the displacement here? Tangent. What is the displacement here? Tangent. BC, sir. Understand? BC. And what is the tangent here? Time? AC. So this is the formula which we used to call as instantaneous velocity. Any doubt? Anybody can ask me. So please kindly note it down. So this is what? The instantaneous velocity. How to find instantaneous velocity from the uniform and as well as non-uniform motion. Is it okay, guys? So this will be very useful at that instant. What is the speed of what is the velocity of the graph? What is the velocity of the body? We can find by using this. Do you understand, everyone? So this is what you have to remember. So instantaneous velocity means what we can say? It is the velocity of particle at a given instant or at a given time period. Then we can say it is the instantaneous velocity. Is it okay, everyone? Clear? Any doubt? So please draw both the diagrams and you have to answer this formula also. So I hope you all understand this formula, Danishkar and Gokul also. So how to find?
Yes, sir.
How to find the velocity from the graph? Slope of the graph will give you velocity. That is how to remember. Instantaneous velocity will given by the slope. So always remember, this is which is parallel to the displacement is the displacement, and which is parallel to the time is the time. So in this BC and AC, which is parallel to the displacement? Anybody? Which is
BC,
parallel to
sir.
the displacement?
BC.
BC. That is why
BC.
distance. Understand? Sorry, displacement. And which is parallel to the time? Arun Kailash?
AC.
Okay. So that is why this is called as EAC. Okay. Ray Danishkar, you also need to communicate. See, you are already not responding. Remaining boys are saying. Okay. So that is what we can say. So AC is the parallel to the time. So that is what is the time period. And the AB is the, sorry, BC is the parallel to the displacement. That is what we can say. It is the displacement. Remember, instantaneous velocity means simply you can say, at a given small period of time, what is the change in velocity? That is what we used to call it as instantaneous velocity. So at a given small period of time, what is the velocity changes here? What is the time period here? At a given time period AC, the velocity changes from where to where? It changes from B to C. Is it yes or no? So that is what we used to call it as instantaneous velocity. Hope you all understand. Is it true or not? Have you understand, guys?
Sir.
That is
Yes, sir.
These are the 4 types of velocities. So before I told you only 3, now you're having 4 types of velocity. So what is the 4 types of velocities?
Uniform velocity, non-uniform
Uniform
velocity,
motion,
average
non-uniform,
velocity,
average
Average velocity, and as well as
instantaneous.
Instantaneous.
So kindly draw this graphs also kindly. Have you drawn? Neatly draw.
Yes, sir.
Use scale and draw. Don't draw freehand. Okay, that is what you have to.
Okay, sir.
So use scale and properly make it. How beautiful diagrams here. Like that only how to make it. So this is all about instantaneous velocity and all. So now you remember. You have to remember, as I told you. So this is all about what is the speed, velocity, and as well as different types of speed and different types of velocity. Now, as I told you, average velocity formula also same thing. It's like average speed. Anybody can tell me formula? We are having 2 formulas for average speed. What is the formulas? Average speed. V average is equals to, what is the formulas? Total distance. Understanding? Total distance divided by total time taken. Yes or no? Yes. This is for
Yes,
what?
sir.
Variable distance in variable time period. But if it is a uniform speed, I said one formula for average velocity. What is that?
Initial speed plus final speed
If it is a
divided.
uniform speed, then we can say V average is equals to, what is that? Initial speed plus
Initial
final speed divided by 2. Is it yes or no? Yes, please
Yes,
respond.
sir.
Same way,
Yes, sir.
velocity also. If it is V average, if it is the V average velocity, I'm saying, if it is the velocity, V average is equals to what? Total displacement divided by total time
Total
taken.
time taken.
Total time taken. If it is uniform velocity or constant velocity, then what is the formula? V average is equals to initial velocity plus final velocity divided by 2. So I am mentioning arrows. Have you noticed it? Have you noticed it? Velocity
Yes,
I am
sir.
mentioning arrow, but speed I am not mentioning any arrow. Have you noticed, everybody? Yes, that is the
Yes,
difference
sir.
between them. So U dash means what? U arrow means initial velocity, and V means what? V means what, guys?
Final velocity.
Okay, final velocity. That is what you have to remember. But here U means what? Here U means what? Initial speed. Understanding? What is that? Initial speed, and V means final speed. That is what you have to remember. Clear, everybody? Yes?
Yes, sir.
Yes, sir.
We have to use which formula? We have to use the right formula in right place always. Total displacement divided by total time taken when variable displacement and variable time period. We will use total display. This is V average formula. If it is uniform velocity, then we can use this formula for calculating V average. Is it okay, guys? Everyone? So that is all about it. So kindly remember this formula also. So V average is equals to what? Velocity. Average velocity is equals to U plus V divided by 2. That is what you have to remember. Is it okay, guys? Yes? That is what you have to remember. So as I said, average velocity of a moving body, sometimes it may be equals to 0, but average speed what? Average speed will never become 0. Is it okay, guys? Clear?
Yes, sir.
Yes or no?
Yes,
So
sir.
you have to remember. So average velocity of a moving body, sometimes it may become 0. Even velocity of a body, moving body can become 0 sometime. But speed or average speed cannot be equals to 0. Understanding? So that is what. So why, sir, means when we are studying the circular path, by the time you can understand. So why velocity is not 0 and velocity is 0, but displacement is not, what is that? Speed is not 0.
Speed, sir.
So why velocity become 0 and displacement not become, distance, 1 minute. So why velocity becomes 0 sometimes, but speed cannot be become 0 anytime because of some reason. That is what? Distance and displacement. So that we will study when we are studying the circular path. When we are studying what? Circular path, then by that time you can understand. So why velocity becomes sometimes 0, but speed will never become 0. Do you understanding? Speed never becomes 0, but velocity becomes 0 in a particular case. So in which case, when any body is traveling in a circular path, then at a particular situation, by this time you might be understand what is the situation also. So particular case, velocity will become 0 and speed will never be going to 0. So which case velocity will become 0? Arun, Kailash, Harish, anybody can tell me. Particular case velocity will become 0. Which case?
Sir, when direction continuously changes.
When displacement will become 0, velocity will become 0 or not? Yes or no? When displacement
Yes,
will
sir.
become 0, velocity will become 0 or not? Yes or no, guys?
Yes, sir.
When the displacement is 0, anybody? Suppose you started with a point and you again reach to a point. What is our distance? I already taught you circular
0.
motion. What is your distance? I am asking. Displacement, not distance. Let me say, please respond. So suppose you imagine you are in a circular path, you traveled at point A. Now you made one complete rotation and you came to again point A. Now what is your displacement? Anybody?
0, sir. Displacement is 0.
equals to 0. So 0 meters. Why? Initial point and final point both will become what? Initial point and final point both will become what? Please respond. Initial point and final point both will become same. So that displacement will become 0. So in this case, velocity is equals to what? Displacement by time. So that 0 by time, which is equals to what? 0 meter per second. Do you understand, everybody? But what is the distance, guys? In this case, if athlete will make, suppose if he'll run one round completely in a circular track, what is the distance? Distance formula. Distance in a circular path. I already taught you. So distance is equals to what? It is equals to circumference of a circle, that is 2 pi r. Yes or no? So 2 pi r. So 2 pi r by t. So 2 pi r distance will never become 0. So that speed will never be 0. Is it okay, everybody? Yes, please respond. So now,
Yes,
why, sir, I am saying, see, if you take, for example, A to B, this is what A point and this is the B point. Now, A to B 1 meter. And now imagine Danishkar started moving from A to B. And after going B, again he reached A. Now, what is the distance? Tell me. What is the distance traveled by?
2 meters.
Traveled by Danishkar. Distance is equals to 1
2
meter,
meters, sir.
which is equals to what? 2 meters. Okay. Now, if Danishkar will stop at point B, what is the displacement? If he will stop at point B, then displacement is equals to what? Displacement is equals to 1 meter. But he reached back to A. He started from A and he reached back to A. Then what is the displacement?
0.
Displacement is equals to 0. Why? Initial point and final point is always same. So displacement means shortest distance between the 2 points. So here you started and finally you reached here itself, then there is no displacement. So if displacement will become 0, so velocity will become 0 or not?
Yes, sir.
That is what. So if we'll make one complete rotation in circular path, if we'll make one complete rotation in circular path, for example, see, you started with the point A and you reached the point B. Then in this case, what is the displacement? Anybody? You stopped at point B. What is the displacement in this case?
2 pi r.
2 pi r by 2.
Harish, shortest distance, Harish. What is this called as? Displacement.
A to B.
Shortest distance, which is equals to what?
A.
Diameter. Do you understand? Diameter it is. Now, suppose if we'll reach to the point A, then if we'll stop at point B, stop at point B, then the displacement is equals to diameter. Okay? And the distance is equals to 2 pi r by 2. 2 will get cancelled. Pi r is the distance when a person will stop at point B. Now, when a person back to A, understanding, when a person back to A point, then he started from here and he reached here only. So at this case, what is the displacement, guys? Displacement is equals to what? 0. But distance is equals to what? Distance is equals to 2 pi r. That is what you have to remember. So this is only circumference of a circle. Okay, everyone, that is what. So whenever the displacement will become 0, then velocity will become what, guys? Velocity also will become 0. But you can see distance is not going to be 0. So speed will never be 0. Will never be 0. That is what you have to remember. Hope you all understand now. Everybody clear? Yes,
sir.
that is what. So this is what about distance and displacement. When the distance will become 0, distance will never become 0, but displacement will become 0 when a body again reaches to the same initial position. Then displacement will become 0. So this is all about the today's class. Hope you all understand. Then with this I will stop. From the next week we'll start offline class. By the time we'll start even solving the numericals also, so that you can understand even more clearly. Okay, so with this I will stop you. I can leave you. So thank you all of you. Tomorrow we'll meet.